Thanks for coming to my session. I'm Trustin, and I'm often known as a founder of Netty project, which powers many large-scale services based on JVM. But in this session, I'm gonna introduce a new microservice framework, Armeria. Instead of being just a marketing pitch, I will show some important design decisions I made for Armeria and the reasoning behind the decisions. So you can learn what factors you must consider when choosing a microservice framework. Someone here might be thinking already, like, what a microservice framework again? Right. But do the microservice frameworks scratch our itches well enough? I think there are some missing pieces, especially when it comes down to RPC, such as gRPC and Thrift. In my opinion, there are five important features of a good microservice framework. Simplicity and the user friendliness are important for any frameworks and libraries. And without a synchronous and reactive programming model, your entire system will stop to function even on a tiny failure. And RPC protocols like gRPC and Thrift are great for building microservices, but you might not be happy with them if your framework does not have proper support for them, uh, and often neglected, but smooth migration from your legacy system and integration with existing technologies are really important because nobody builds a service from scratch. Lastly, um, it's also it's also good to think about client-side load balancing because client-side load balancing can uh, provide a less number of points of failures. So let me start with some simple examples first to give you the basic understanding of Armeria API. And to be honest, it might not be as simple as you expected because this level of simplicity is pretty common these days. But don't be disappointed. It will be more and more interesting as we go. So this is a simple Hello World server. We created a builder and specified HTTP and HTTPS port 8080 and 8443. And during the development phase, we often use a self-signed certificate. So Armeria provides a shortcut method called the TLS self-signed, which automatically generates a self-signed certificate for you. And Armeria also supports HAProxy protocol. So you can work with load balancers like AWS Elastic Load Balancer. And also, what's interesting here is we specified port number 8080 for HAProxy, and this is the same with HTTP port. But this is not a mistake. Armeria can auto-detect the protocols by looking at the first few bytes of the traffic. So it can be very useful when your environment is pretty restricted, like some firewalls. And now we bind some service at hello name, and name is a path variable, and we retrieve the path variable from the context object by using path param method, and then we format it into a response object. And then we build and start server. Pretty straightforward, right? You can also write your services using annotations like you can do with many popular web frameworks. The only difference from the previous example is that now the path variable is automatically injected as a parameter and you can return a string directly because Armeria will perform parameter injection and response conversion automatically for you. What about gRPC? Once you compile your .proto file using the official protobuf compiler and implement your service logic by extending the abstract class generated by the protobuf compiler, all you need to do is to build a gRPC service using a builder pattern and bind it to the server. You might think like, hey, we can do this without Armeria, but this is only a tip of iceberg, so please be patient. And Drift is pretty much the same too. You compile your .drift file using the official Thrift compiler and implement your service logic by implementing the interface generated by the Thrift compiler. When you wrap it with a HTTP service and bind it, uh, now you have a full HTTP2 based Thrift server, which is not yet possible with the official Thrift for Java. Now it's getting a little bit more interesting. You can mix and match your services in whatever way you like. Here, our Armeria server can now serve REST, gRPC, and Thrift requests all at once. As I will show later in this talk, this is extremely useful in production systems. Now that we know how Armeria API looks like, let me explain why Armeria chose asynchronous and the reactive programming model. Again, some of you might still think like our service is not that big enough, so maybe we don't need to go asynchronous. But the reality is, synchronous services will hold your bag really soon. Let's start from a very typical synchronous microservice, which receives a bunch of requests from the clients and accesses many shards of backends for the clients. We usually split the backends into many shards so that the data access is distributed evenly and nicely. And based on the request, the service will determine which request should go to which shard. In this diagram, uh, there are three shards and four worker threads. The worker threads drain the pending request from a queue and performs the actual data access. Because all shards are operating normally and optimally, the time spent for each shard is same, right? However, let's just say the second shard started to fail, responding very late. How often will this kind of failure happen in production and in a larger scale system? It is every day actually. So, because of the failure, the worker thread 2 will take much longer than usual to handle the request for the second shard. Because the two other shards are okay, the time spent for the second shard starts to dominate. And then, as a result, all worker threads will spend most of their time for doing nothing but waiting for the second shard. At this point, the service is barely functional, not functioning at all. Even for the requests that go to the first and third shard, it will not work because uh, the time spent for the second shard is really dominating. This defeats the one of the main purposes of sharding. In a microservice architecture, this kind of failure is propagated to every service in your system, which is often called cascading failure or domino effect. It is really painful if this happens in production because every stakeholder of every service will be in trouble. So, how could we solve this problem? How about adding more CPUs? If you look into the metrics of the systems suffering this issue, they are actually very busy. So they are just waiting for the backends to respond. So there's not much use to add more CPUs. And how about adding more threads to the thread pool? I think it's not a good idea either. No matter how many threads you add, they will get busy like other threads in no time because they have to wait for the timeout. Each thread also requires additional memory for its own call stack and it increases uh, the context switches between threads, which consumes CPU cycles unnecessarily. So as a result, the system becomes very fragile, and even if just a single shard or a single backend fails, the system will stop to function correctly. And also, even if you try to address this problem by adding more CPUs or whatever, then it will result in inefficient system resource utilization. But of course, there are some workarounds like splitting thread pool for each shard, or tuning the maximum size of the call stack and increasing the number of threads. But the fact is, you have to keep tuning it whenever something changes in your environment. For example, you need to reconfigure your system whenever the number of shards change, but instead, uh, we just chose to go asynchronous at company I work for. Uh, as a result, it became much simpler. It's often enough just to look into two parameters: total memory size and the number of event loops. So getting too many requests, then we can just increase the heap size and tune some GC parameters, and you're mostly fine. Now we know why a synchronous programming model is important, but it's not the only piece we need to build a robust microservice. Um, it also has to be reactive. Why do we need to be reactive? Why does it matter? It's because it helps your service not blow up with out of memory error under high load or while handling a large amount of data. Let's say we have to spend 10 megabytes of personalized response for uh, 100,000 clients at the same time. Of course, you cannot hold them in your memory at once because it's uh, 1 terabytes if you do some simple calculation. So we need to stream it. When we stream the data, we have to be cautious about the speed of data production, because if we produce our data too quickly, then the client will not be able to consume it quickly enough. Then it will be buffered on the server side, and then the result is out of memory error again, even if we try to stream the data. So what's important is to buffer just enough. So here's a diagram that shows the difference between traditional services and reactive services. A traditional service often loads the entire data set required for building a response and send the whole response at once. A reactive service usually interacts with a client, loads only as much as the client requested for, so that the memory consumption stays minimal and only up to the point where the client can handle. Because everything in Armeria, both the client and server, is asynchronous and reactive. It is extremely easy to write a reactive proxy server or API gateway. Here, we simply forwarded the received request object to the client. And so that's a proxy server in just 6 lines. Of course, in reality, you're gonna have to add or remove some headers. So if you're interested, you can take a look at the example, the complete example later. And many microservice architect frameworks, including Armeria, is based on HTTP, but it does not mean it supports only RESTful APIs. There are various compelling alternatives to REST in microservice architecture, and RPC protocols like gRPC and Thrift are good candidates. If you are considering gRPC or Thrift, you must check if your framework you're going to use provides the same level of support as HTTP for RPC. And this is a simple example of a usual RPC call over HTTP, which it has failed at business logic level. If you look into the response, even if the request has failed HTTP status is 200 OK, which means success, ironically. It is so it is pretty common for RPC protocols to use 200 OK and put the actual result into response body. HTTP-based frameworks often do not provide the information like method name, parameter names and values, and return values, or exception of RPC calls. They are hidden under the cover. How about access logs? If you look into the access log files written by application server, you see the same problem. Uh, you barely get what you want, right? So Armeria tries to solve that problem by providing a dedicated API for accessing a request log in programmatic and structured way. We record a lot of information, low-level timings such as DNS and socket level timestamps, HTTP level requests and response headers, and first a few bytes of first 100, for example, bytes of a request response body, and most importantly, RPC level properties like service type, method name, parameters, and return values. And you can even attach some custom attributes specific to business logic, like the current user ID. But before showing the actual API for request logs, let me explain a simple concept called the decorator, because it's essential to understand how structured logging works. Uh, it's basically a design pattern for separation of concern. You can decorate any Armeria service using a decorator, using the decorate method. Like in this example, the delegate, which is the next service. Uh, like in this example, in a decorator, you are given with three objects. The delegate, which is the next service or decorator in the request chain, and the context and request. Inside the decorator, you can intercept a request or perform an operation on a context object. Many features in Armeria are actually implemented as a decorator, so please keep in mind what I'm gonna show in this presentation are also mostly decorators. To retrieve the request log, you need to first intercept a request using a decorator and then add a listener to the request log. We cannot get all the information or all the properties immediately because everything is asynchronous in Armeria, and that means the request has not been handled completely yet. So we add a listener so we are notified when everything is fully available. Here's an example implementation of the request log listener. As you see, we can retrieve uh, the properties for RPC requests and responses. It's not shown in this example, but there are a lot more you can access here. Like this. At Line, the company I work for, we serialize the request log and send it to Elasticsearch via Apache Kafka and search them using Kibana. As we see, there are many useful information here, like the type of the mobile app and its version, RPC request parameters in JSON, the client IP address, RPC service and method name, the request ID, and the RPC response in JSON, and which server handled the request, the user ID and location, etc., etc. This comes almost for free, thanks to Armeria's logging API. It even provides the decorator that sends the log to Kafka out of the box. So it's pretty easy to record all the request logs. Another long-standing issue of RPC is that it is often hard to make an ad hoc call, like sending an RPC request without any ID setup. So far, we had to find the proper service definition file, such as .proto or .thrift, and set up the development environment like build a tool and IDE, and then write some code that actually making code RPC call. And as you know, it takes time and energy, right? In contrast, for HTTP, you can just write a tool, you can just use a tool like a CURL or even just use a telnet command. So we tried to make something more convenient and even collaborated in Armeria, which is called the documentation service. If you add it to an Armeria server, it will automatically scan all supported services such as gRPC and Thrift and provide a web-based UI for browsing and invoking them conveniently. In the future, we hope to extend it into something bigger, like providing a monitoring console or a configuration editor, like browsing the current server metrics or adjusting log level. So this is a screenshot of doc service, which looks pretty similar to Java doc, right? On the left pane, there's a list of services and their operations. Once you click on operation, you will see the detailed information about the operation, like the human readable description, parameter list, return types, and exceptions it will throw. And if you scroll down the right pane, you'll see a form like this. Once you enter a request in JSON format and click the submit button on the bottom left, the request will be sent to your server. This means the inconvenient steps like uh, looking for .proto or .drift file or setting up an IDE, they all become completely unnecessary. On top of that, once you submit a request, your browser URL location will contain the request encoded as a request parameter. Let's say you found a bug which is triggered by a certain request, then you could just share this URL with your colleagues so that so they can reproduce the problem very easily. They do not need to set up anything. They can just enter that URL into their browser. This level of simplicity and convenience was not possible before in other frameworks. Besides structured logging and documentation service, Armeria offers some additional features not available in the official uh, gRPC or Thrift implementations for Java. For example, Armeria supports both HTTP 1 and 2 for both gRPC and Thrift. And gRPC web support is also provided out of the box. So it's very easy to interoperate with your front-end apps without setting any proxy server or sidecar. There's no need for them. And please also keep in mind, Armeria has decorators to solve many common problems, which are sometimes not available in the upstream, like official gRPC or Thrift implementations. For example, um, Armeria provides out-of-the-box decorator for metric collections, distributed tracing authentication, request throttling, and circuit breaking, and automatic retries. And do you remember the mix and match example I showed earlier in this talk? It's not only for gRPC and Thrift. You can mix and match all kind of things in Armeria. You can serve a REST API, static files, health checks from load balancers, even traditional web apps based on Tomcat or Jetty, all on a single TCP IP port and in a single JVM instance. This mix and match ability is extremely useful in production because the service is not homogeneous but often heterogeneous in real life. Speaking of heterogeneous, it's not always about programming languages and protocols, it's also about the libraries and frameworks. Each organization chooses different technologies because they face different challenges uh, from each other. It basically means a microservice framework needs to be unopinionated, when integrating with other technologies, because we don't want any restrictions when we choose our favorite library or framework, right? That being said, our Maria team made an early design decision that works well for diverse third-party technologies. Some microservice frameworks today try to provide many features in wholesale manner, like to use this, you have to use this and that, and so on. But that's absolutely not the case for Armeria. Um, Armeria only focuses on what it does best and lets you choose what you like. You can choose your favorite dependency injection frameworks, data access libraries, as well as the protocols. All these features of Armeria, like an opinionated integration and the ability to mix and match services, made Armeria ideal for various use cases at production. So let me show some real production use cases. I think most of you already know about Slack technologies, the chat-based collaboration services. Slack was using Thrift since 2015 as their internal RPC protocol, but they chose to migrate to gRPC because of various reasons. However, because the switch from Thrift and gRPC can happen all at once, they had to run both gRPC and Thrift until all services stopped using Thrift. As you know, Armeria is perfect for mixing Thrift and gRPC, right? Um, so they also utilized various out-of-the-box service implementations, like Prometheus exposition service for exporting server metrics to Prometheus, and to work with load balancers, they used health check service, and they used Brave service for distributed tracing, and of course doc service for their convenience of invoking RPC services. And this is a part of their production code I copied from their slides. As you see, they first add service like health check service, doc service, and then add various custom services, including Thrift and gRPC. And now their migration is success. Line, and this is the company I work for, is I think most of you do not know about Line, right? Because it's not a dominant uh, mobile messenger here, but it's actually uh, the company who runs a mobile messaging service similar to Telegram or WhatsApp, and it has #1 market share in Japan, Taiwan, and Thailand. And Armeria is being used for many parts of the services, but here I will focus on in-app sticker store. Previously, it was built using Spring Boot and Tomcat, running synchronous Thrift services on top of servlets. It was using Apache HTTP client for talking to other services. But because they kept facing the cascading service failures already, we mentioned about that, right? They wanted to switch to a synchronous programming model. However, their code base is pretty huge, which is no surprise. So they wanted to keep their existing legacy and then add a new asynchronous Thrift implementations. And this time again, Armeria can do its job. So they replaced the Tomcat with Armeria. As a result, the is a, Tomcat service serves the legacy business logics, and then the new Thrift services will be handled by Armeria server directly, which means there's no overhead of using Tomcat or Servlet anymore. And also they used Armeria's HTTP client with the client-side load balancing, which I'm gonna talk about a little bit later. So the result is pretty dramatic. So today, most of their services are fully asynchronous, and the result is dramatic. For example, here, by making three asynchronous calls into three asynchronous calls, they reduce the latency by almost 5 times. And by using HTTP2 clients, they also reduce the number of the HTTP connections between microservices, this time more than 100 times. This reduced the overall resource utilization and latency of the system, of course. And because enabling distributed tracing is a piece of cake, because it's as simple as adding a decorator to a service. So by adding Brave service, they now get the detailed call timing information between microservices, like this screenshot. Here, the get product v2 RPC call on the top is taking about 24 milliseconds. Thanks to the distributed tracing, we know that it's not because get product v2 is slow, but just because three other remote calls are taking a long time, like get user info by access token and get product detail and get product ownership. The last case I'm going to show is a project which was built from scratch. This is about a company called Kakao Pay. It's a Korean company which is behind the popular mobile payment service in Korea. They built a service called the Firm Banking Gateway, which is required when talking to Korean banks via value-added network. They wrote the gateway in Kotlin, pretty experimental, from their banking, from their business category. But anyways, when using Kotlin, it can be somewhat annoying to work with the Java library because of nullability issues. However, it's not the case for Armeria because it's using nullability annotations everywhere. So this time, the development team chose to mix and match Spring WebFlux-based web services and gRPC services. Uh, like Armeria replaced Tomcat in the previous case, this time they replaced Reactor Netty, which is a networking engine under the hood of Spring WebFlux. So Armeria replaces Spring's network layer, Reactor Netty. And then gRPC services are handled directly by Armeria, which means there's no overhead for WebFlux at all. And they are all handled in a single virtual machine and single TCP/IP port. So far, this talk was mostly about receiving requests, but sending requests also has an important role in microservices. Should we send a request to a load balancer to talk to a cluster, or should we use client-side load balancing? Each option has its own pros and cons, but in my opinion, it's often better choosing client-side load balancing. Let me show you why. Load balancers or reverse proxies were the options people chose traditionally when creating a cluster of the same services. And they provide the load, they distribute load very well, offload overhead of handling TLS, and performs automatic health check periodically, like every few seconds. And it had a kind of service discovery because everything the client has to know is just the load balancer address. However, having a load balancer in the middle means many disadvantages as well. More points of failure, increased latency, and potentially uneven load distribution if your load balancer does not understand HTTP2, and cost of operating load balancers. So Armeria tries to solve this problem in two ways. The first part of the solution is client-side load balancing, which lets a client discover the available host and choose the target host autonomously. It currently supports Kubernetes-style DNS records and Apache Zookeeper as a discovery mechanism. And the second part of the solution is, of course, using Armeria, uh, which ships OpenSSL-based high-performance TLS and dev epoll transport from netty. And again, you can run different types of services in a single port and JVM, so there's not really a need for load balancers on API gateway. There's no need for load balancers or API gateways. And this simplifies your microservice architecture quite a lot because you don't need to deploy an additional proxy server. If you are currently using a traditional L4 load balancer or if your load balancer does not understand HTTP2, you might have a problem with HTTP2 connections because an HTTP connection is kept alive very long, right? As you see from this graph, some of our services had an issue with the load distribution for HTTP2 requests because the load balancers we were using did not understand HTTP2. At one point of time, the difference of incoming requests between two nodes was more than 100%. However, after applying client-side load balancing, the problem is completely gone. And as a bonus, if you use Armeria both on the client and server side, uh, a special HTTP2 based health check mechanism is enabled. Armeria client will send a long polling health check request. This reduces the number of health check requests significantly, like from every 10 seconds to every 5 minutes. Also, because it's long polling, a server can notify its status change immediately, which is way more efficient and accurate than doing health checks every few seconds. Of course, this is a fully backwards compatible because it's enabled only when a server tells that long polling is supported. And this is an example that shows how you can implement a client-side load balancing with service discovery in just a few lines. I also added automatic retries and circuit breaker to make it more interesting. First, you create a DNS-based endpoint group and wrap it with a health-checked endpoint group, so only the healthy endpoints are selected. And then we register the endpoint group named my service with a preferred load balancing strategy, which is weighted round robin in this case. And then we create an HTTP client with the group name my service here and added a circuit breaker and automatic decorate added a circuit breaker and automatic retry decorators. So every request are protected by a circuit breaker and automatically retried. And of course, this client is asynchronous and reactive. Okay, we covered various important aspects to consider when adopting microservice architecture and how they affected the design decisions when building Armeria. However, it's not the end of the story. There are still many things to do, in my opinion, and so it will be amazing if you could give it a try and report bugs or suggest a new feature. We're going to be very happy. So Armeria is currently at version 0.95. There are still some tasks left, like API stabilization and overall cleanup, but we expect to have 1.0 released before the end of this year. So I think it's a really good time to give it a try and start playing with it. After releasing 1.0, we want to add more bells and whistles like DSLs for the languages like Kotlin and Scala, and also improving the documentation service uh, and making it better and bigger, and also adding more transports like WebSockets and Unix domain sockets, adding more decorators and service discovery mechanisms. And we also hope to add Open API specification generator for better interoperability. And Armeria already performs pretty well in production, but we want to make it even better. So I hope you like this talk, and if you are interested in Armeria, please visit our GitHub repository. You can go there by scanning this QR code, and please think about starting us and following our Twitter account. And thank you very much.
Now we have some time for questions. Any questions? Just raise your hand.
Hi, first of all, thank you for your great topic. And actually, I want to ask you about, like, you touched the gRPC, Thrift, but actually in our company we use maybe also, you know, Dabbo a very lot. So maybe you have support for it, or maybe just plans to maybe
Oh, that's a
use it.
good question. We actually received a feature request for Double, but as far as I know, it's not based on HTTP, right?
Oh, Dabbo, yes, it's RPC based.
Right, right. So the problem is that currently Armeria is fully based on HTTP protocol, but the plan is to support more RPC-like protocols. For example, RSocket and Double could be one of them. So we are definitely interested in doing that. But I think it will gonna be after 1.0. But I am definitely interested. So please stay tuned. Please stay tuned.
Okay, thank you.
Thank you.
Any more questions?
If you have any questions, I'm gonna be in the discussion area for uh, 10 or 20 minutes. So please come there and say hi to me.
Okay, so first of all, thank you, Trustin, for a great talk. Okay, thank you for a great talk. And I have actually a question on one of the maybe it was the first slide. First, with the code, there was an example of using HAProxy directive in a builder. So, does it mean that this framework allows us to make the framework create a HAProxy behind these services, the reverse proxy, to work with them?
I think it's absolutely possible because you can just use it as an HA proxy server, but as long as the protocol behind HA proxy is HTTP.
Okay, and in that case, is it possible to configure, make some smart configuration of that proxy using like inline code? So, for example, to configure sticky sessions or maybe some like custom distribution of requests between these services.
I think it's possible because in let's say you have built a server which is a proxy server, and then it means you are gonna bind some service which proxy is the request to the backend services, right? And then the service could look into the received request and choose to route smartly. So I think it's definitely possible.
Okay, thank you very much.
Thank you.
Any questions?
Thank you for your speech. And my question is, what is the killer feature of your framework, what you presented today? And for me, for instance, for me to start use it when I go back to work on my pet project, something. But
Thank
You
you.
know, there is a lot of frameworks as Ktor, Micronaut. So what is the reason for me? I mean,
Oh, okay. So is it better than other? What is it better than other frameworks, right? In my opinion, the power of Armeria is that it is designed to integrate with third-party technologies from the ground up. So, for example, when you use some other frameworks, uh, then you have to use their own dependency injection framework, for example. But in reality, you already have services built on top of an existing technology like Spring Boot or whatever. Then in that case, you do not want to migrate everything all at once. But Armeria allows you to migrate things one by one without much configuration complexities. I think that's the biggest strength of Armeria.